Welcome to my channel, dear student. This is class about the vector, and some B friend asked me to solve the question by the vector method, that is sin a plus b, sin a minus b, and cos of a plus b and cos of a minus b. This trigonometrical formula can be proved or not by the vector method, and that is your question. Students, see carefully. This is very important for all of students who want to appear the semester exam for math honors and also BSc and also BTech. And also this is a very important class today for the JEE Main and Advanced. Okay, and see carefully. And here is the axis, that is OX and Y. We take the two vector, that is OA, make an angle alpha, and vector OB, make an angle beta. And you know, along the x-axis, always this is the unit vector. Along x-axis is I, and along y-axis be j here. Okay. Now find the vector OB and OA. This is the proof. This is your question, that is sin alpha minus beta, and that is sin alpha cos beta minus cos alpha sin beta, and also sin cos of alpha minus beta. This be here cos alpha cos beta plus sin alpha sin beta. Okay. And from the triangle, here I and j be the unit vectors in two rectangular axes OX and Y. Let OA and OB vector makes angles alpha and beta with x-axis, that is OX, which is shown in figure 2. Let OA, this is the magnitude length, this is R1, and OB, that is R2. Now for the triangle OA plus OAD, we can write here OA plus AD plus DB equal to 0. Then OA is equal to minus AD minus DO equal to vector DA plus vector OD. Okay. Now cos alpha from trigo we can write here, that is OD by R1. So this is OD equal to R1 cos alpha, and sin alpha, that would be here DA by R1, that is D equal to R1 into sin alpha, and this is the magnitude of these two sides. Now dA is equal to, this is the vector dA. We can, and along dA is the along j vector, so we can write a j unit vector. So j times of R1 into sin alpha, and OD vector is equal to I times of R1 into cos alpha. Okay, and then see that is the cos beta. Cos beta we can write here OC by R2. Then OC is equal to R2 into cos alpha. This is the magnitude of this length. Now sin beta, same as we can write here CB by R2. Then CB is length is here R2 into sin beta. Therefore the OC vector, this is OC. OC vector, this is the along I vector, that is I into R2 into cos beta, and CB vector, this is along OY axis, and this is the J vector, J times of CB, and CB means here J times of R2 into sin beta. So therefore OA is equal to DA plus OD, and that is J times of R1 into sin alpha plus I times of R1 into cos alpha. And again for the triangle of OBC, this is OB plus BC plus CO equal to 0. Therefore the vector OB is equal to, can be written as CB, vector CB plus vector OC. And CB, it is the J times of R2 into sin beta, and OC is equal to I times of R2 into cos beta. Therefore OA dot OB is equal to, can be written as we found these two vector here, R times into sin 1 R1 into cos alpha plus J times into R1 into sin alpha. Dot OB means I times of R2 into cos beta plus J times into R2 into sin beta. So therefore the dot product, from dot product we can write here R1 dot R2 into cos of angle between them, there is the difference between them two angle, this is alpha minus beta. Angle between the vector OA and OB is equal to alpha minus beta. Okay. Therefore we can write from the dot product see, I take common r1 and r2, then we have left one is the two vector I1 into cos alpha plus j into sin alpha into I1 into cos beta plus j into sin beta. So doing dot r1 I1 into dot I into cos alpha cos beta plus I into dot j cos alpha sin beta plus j dot into I sin alpha cos beta plus I dot j into sin alpha sin beta. You know I dot I equal to mod I into cos 0, I dot j mod I mod j into cos 90. So I dot j is 0, I dot I is 1, j dot j is 1, j dot I is 0 here. So from that we can write here cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Okay, simple calculation. And see, this is proof here. Now again way crossover, we doing way crossover, we want to get here the sign alpha minus beta, that's why doing cross. So now way vector is r1 I into r1 into cos alpha plus j into r1 into sin alpha, and same as the vector ob are put here, and doing dot product, this is r1 r2 into sin of alpha minus beta, and take common modulus of that. So take on r1 and r2, this is mod of r1 r2, we got here the I cos alpha plus j sin alpha, and same as the ob here, doing cross here, I cross I into cos alpha cos beta, I cross j into cos alpha sin beta, j cross I into sin alpha cos beta. Okay, now see I cross j, that is actually, this is the k vector, j cross I, that is equal to actually minus k vector. See, so now I cross I, angle between them is 0, so I cross I is there 0, but I cross j here is k times of cos alpha sin beta, and j cross I is here is minus k. Okay, and j cross j here is 0, so mod k here is 1, and now cos alpha sin beta minus sin take on k modulus of k as we take mod. So length of k here is 1, as we know this is the unit vector. So sin of alpha minus beta mod k into cos alpha sin beta minus sin alpha cos beta, sin alpha sin beta, I am saying wrong, this is sin beta, sorry, sin alpha cos beta. So this is take plus minus here, so we can write as sin alpha cos beta minus cos alpha sin beta. Now to be determined which sign would be acceptable. If we take beta is equal to 0, see what happened here. Then left hand side this is sin alpha minus 0, then sin alpha. On the right hand side this is plus minus sin alpha cos 0 minus cos alpha sin 0. We got here plus minus sin alpha. See, on the left hand side there is a sign, but on the right hand there is, we got here plus minus sign. So sign negative sign not to be acceptable. So take positive sign, sin alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. This is the formula which is derived here. Thank you for watching my video, everyone.